Hello and welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video we start off a new chapter and we're looking at the topic of linked lists. Now linked lists are one way that we can use to implement the list or sequence ADT. So in our last chapter we talked about the abstract data types of stacks and queues, which were very limited forms of abstract data types. In this chapter we're going to take a step up and look at a slightly more powerful abstract data type, which depending upon where you're working with it, might be called a list, might be called a sequence. In the Java libraries, there's an interface, an abstract type called list, which represents this. In Scala, it's probably better represented by the sequence. And so if we go and we look in Scala at the sequence, we have, as with all of the aspects of these Scala libraries, a great many different methods that are in here. Really, a lot of these go above and beyond what we want. And so if I were to create a trait, I'm actually going to call this one my list because conflicting with list is not a good idea. The basic capabilities that I want on my list are the ability to add an element, and the adding could be done normally kind of as a random access. So I can add an element at a particular location. I can remove an element from a particular location as well. And I can get elements, which of course in Scala I wouldn't write this as get, I would normally write this as apply. Okay. Unlike our, and then it might be helpful to have the ability to check for an is empty and a size. Def is empty is a boolean, def size is an int, etc. So there are other methods that we could add on here, but the functionality for this, the list ADT, really is the ability to pull out elements from anywhere inside of it, to add them and to remove them, once again, wherever we want. And hopefully you can see this is fundamentally more powerful than the stack or the queue, because those ADTs had a very rigorous way for us to access them. We could only add at one place, either the top or, for the queue, the back of the queue, and we could only remove from one place as well. For the stack, we removed at the top. For the queue, we removed at the front. And that was it. We couldn't go and look up random elements inside of there. So the list is more flexible. I often tell students that a list is a concept they're used to. Your grocery list is a list. And technically so is the list that we've been playing with in Scala, because that list happens to implement the sequence interface. Now, to take a step beyond this, when we talk about how we represent this in the Scala libraries, note that what I've written here looks mutable. Okay, I'm mutating things. If I didn't want to mutate things, I would be returning a new list of this type. Okay? And then removing would also return a list, and apply would return a list. So there's a nice distinction between whether your list is mutable, in which case then add remove can actually just alter the existing list, or whether it's immutable, in which case they need to leave the existing list intact and return a new list. So we could implement one of these with an array. We'll talk about that some in the next video. And then we'll talk about the nature of a linked list and look at how we can implement one of these with a linked list and see how a linked list is different from an array as far as how it's